Hello and welcome to another video. In this video, we will cover loops. Now, loops are basically a technique to iterate a collection data structure like lists or tuples. Okay, so we'll go through the different constructs of using loops like for loop, while loop, and we'll also explore a trick that Python has up its sleeve. It's called list comprehension. So let's go through it one by one. So as always, we'll declare the all too familiar planets list that we have done in previous videos. So the construct goes something like this: for planet in planets. So what this piece of code will do is loop through every element there is in the planets list, and every time an iteration happens, the variable called planet will assume one of these values of this list. Okay, so if this is what I declare, every code block that is indented below this for loop will execute as many times as the length of this list. So basically for this, it will execute 8 times. And then for each time, the planet will assume different values in each iteration. So for first iteration, it will do Mercury, then Venus, then Earth, then so on. Okay. Now we are printing it with an end separator of space. So we'll probably see all of the planets printed with a space separator. Okay. On the same line, separated by a space. So if I execute this, then you'll see that the output is exactly as desired. Okay. So the for loop specifies two things: the variable name to use. So in this case, we did planet. You can do anything you want, right? So as long as you keep the variable names consistent, you'll always end up getting the same output. I don't care what the variable name is going to be. And then the second part that the for loop specifies is the set of values to loop. In this case, the collection or planets. Okay, and then there's a word in to just link them together. So the object to the right of the in can be the object that supports the iteration, and basically it can be thought of as a group of things. You can probably loop over it, iterate over it. In addition to lists, we can iterate over the elements of a tuple. This is also a collection. So we have declared this tuple called multiplicants, and then for each element in the multiplicants tuple, we basically do product equals product times mult. So what this will do is do 2 into 1 in the first iteration, and that will store up the answer 2 in the variable product, and then the next iteration will do 2 into 2 because that's now the current value of product multiplied by the second element, which is 2 in this case. So it will do 4, then 8, then 24, and so on. Okay, so we see that the output rightly comes down to 360. Okay, now it turns out there are some liberties that you can take while using loops. So a string can be thought of as a collection of characters or an array of characters. So what you can do here is treat a string as it's a list, and if you iterate over that, so for each character in the string S, the car will basically support each character inside the string, and then I'm just printing that character if it is uppercase. Okay, so again, it's another built-in function that comes to us for every character that we have in Python. That is, we can check whether that particular string is uppercase or lowercase. So obviously it will print the H, and then it will print the E, and so on, all of the things that are uppercase over here. So you see all of the uppercase characters get printed. Okay, so now let's discuss range. Now let's say you want to iterate 10 times over some business logic that you're implementing, or a finite amount of times for which you don't have a collection right now. You just want to apply some logic and want to do it n number of times. Now there's a convenience function for that. It's called range. Now if you specify for some variable in range, what it will do is loop through this starting from 0 all the way till 4. Again, 0 based indexing n minus 1. Please remember that. So this will print out doing important work I equals 0 all the way till 4. It won't cover 5. Okay. Now, is for loop the only way to implement loops? No. There is also something called while loops. Okay. So the other type of loop in Python is a while loop, which iterates until some condition is met. So essentially, when you're doing while loops, think of it as conquering finite space. If you have a list or a tuple, or you know exactly how many times I want to run a certain amount of iterations, for loop is your best friend. But when you want to iterate based on a condition, so keep doing this until a particular condition is met, then you leverage while loops. So let's go through an example of that. So let's say I have declared a variable called 0, and then while I is less than 10, again, it's a Boolean comparison or a Boolean operand, which will always resort to true or false. So after while, this always has to come to either it has to evaluate to true or a false. Okay. So if it evaluates to true, the piece of code that is indented below the scope of the while loop will get executed as many times as the while loop is true. So we can clearly see that we're printing I and then incrementing I by 1. Okay. So this is again in place operator. It's basically short for I equals I plus 1. Okay. It's another convenience syntax you can use. Now, for the first time the loop goes in, I is equal to 0. So is 0 less than 10? Yes. So it goes in and prints, and it goes on and on and on till the value of I is 10, because 10 is not less than 10. So the idea is it will print everything from 0 all the way till 9. Okay. So the argument of the while loop is evaluated as a Boolean statement again, and the loop is executed until that statement evaluates to false. So anytime that condition evaluates to false, it will exit the loop and this will stop iterating. Okay. Next, let's discuss list comprehensions. So list comprehension is one of Python's most beloved and unique features. Again, like I said, it's a trick up Python's sleeve that other programming languages do not have. The easiest way to understand them is to probably just look at a few examples. So let's go through them. So we have the squares variable, and what we are saying here is this snippet is familiar, right? So for n in range of 10. So this will start from 0 and iterate all the way till 9. And then for each of those iterations, what I'm doing here is taking the exponent of that particular number. So for 0 squared, it will be 0, 1 squared 1, 2 squared 4, 3 squared 9, and so on. Okay. And then I'm enclosing this whole expression in square brackets, which essentially means squares will be a list, and every element of that list will be the square of the numbers that range between 0 and 9. So I'm expecting 0, 1, 4, 9 all the way till 81. So let's look at it. Again, there was nothing stopping you from writing the same piece of code. So I can always say for, let's say, declare an empty list like this. And then for I in range of 10, let's say, I squares dot append I exponent of 2. Okay. Now if I do this and then check what is the value of squares, you'll see that we get the exact same thing just like below. But look at the difference in syntax between these two. How elegant and sleek this looks, right? So again, that's a very handy trick up Python sleeve. So I've written down below how this would have looked like if it weren't for list comprehensions, and the same way to do it with an existing list. And now turns out you can complicate this further. So what you can do in a list comprehension is also incorporate if statements so that you can conditionally pick up and process elements in a list. Okay, so let us pass through this statement. So again, this is familiar territory for planet in planets. So this will go through all of the iterations required to exhaust the planets list, and then from there it'll check if the length of planet is less than 6. What does this mean now? So again, if you remember, if I have a string here, if I loop through the string, it will iterate through every character, right? So that means it seems to have the properties of a list. So we already know that the length of a list is checked by the len function. So if I check the length of a particular string, it gives me the number of characters that there are inside that string. So if I take the length of a planet, it will give me the number of characters in that string. So for example, Earth has 5 characters, but Uranus has 6 characters. Okay, so my expectation is planets like Earth or Mars will get picked up. Planets like Uranus, Mercury, which have more than 5 characters, will not get picked up. So based on this condition, I will pick planet for each planet that exists in the list planets, if and only if this particular condition is met. So let's check that out. And you see, only Venus, Earth and Mars get picked as part of the final output. Now again, imagine if we had to implement it in code. So let's say I would have done short underscore planets, declared them as a blank list because I'm going to append it as I go along. And then for planet in planets, I will ask whether the length of a planet is less than 6 or not. And if this statement is true, then I will append that particular planet inside my short planets list. So if I take a look at the short planets right now, again you'll see the outcome will be absolutely the same. Okay, so again, imagine how much this got reduced to just because you have list comprehensions. Do you absolutely need it? Of course not. It's just a very sleek and elegant way of representing. Okay, now for those who are familiar with SQL or SQL, you might think of this if statement as being a where clause. Okay, again, if you don't know SQL, just don't sweat over it. Skip over to the next section. Here's an example of filtering with an if condition and applying some transformation to the loop variable. Okay, so again, if you break down this list comprehension that we have in front of us, for planet in planets, this is the iteration part, and then this is the condition part. So again, this is the same condition that we've seen before. So all of Venus, Earth and Mars get picked, the rest don't. Okay, and now instead of picking planet for what it is, just like I've done it here, I'm going to say planet.upper. So I'm basically transforming all of this into uppercase. So there'll be capital V, capital E, capital N, capital U, capital S. Okay, and then I'm adding an exclamation mark. I'm concatenating an exclamation mark next to that planet's name. Okay, I'm naming it loud short planets, and again you'll be able to see that all of the planets have been capitalized and an exclamation mark has been added to them. So again, people familiar with SQL, this acts like a where clause, and this is something that I can do is a morphed version of the select statement. Okay, so there we go. Again, people usually write list comprehensions in a single line, but just like we've seen in the previous videos for Boolean comparison, you can easily break it down, make it multi-line, make it more readable, make it more maintainable. So you can say planet.upper plus exclamation mark on the first line. That is the thing that you want to produce. This is just like a select statement. And then for planet in planets, this can be related to from statement in SQL. And then this can be the where clause, where you have the if condition. Okay. Again, yields the same thing. Okay. So there we go. Okay. So continuing the SQL analogy, you could think of these three lines as select from and where. Okay. So that's the same thing that's written. So I'll skip over that. Now, let's compare these two pieces of code. Again, I'm trying to justify the readability part of it and the minified version or the minified part of it, how this makes it more sleek. Okay. So you have count negatives with a doc string, and then you declare an n negative integer as 0, and then for the list that you provide as inputs, I'm trying to count if num greater than 0, n negative equals n negative plus 1, and then return that n negative. So essentially what this function is doing is, if you provide a list of numbers full of positive and negative numbers, it will count the number of negative numbers that are there and then return you an output, in which case for this example this will be 2, just like so. Okay. Now the same solution using list comprehension looks like this, just a one-liner. Okay. So again, let's break it down further. So for number in numbers, this is the iterator part. If num less than 0, you consider that number, take that number into account. So there goes our list comprehension. Now I know for a fact, since I've filtered out this list will only contain the negative numbers, and now all I need to know is the length of this particular list, right? So I can easily return the length. Now, just for demonstration's sake, let us make sure we're getting the same output out of these functions for the same inputs. So I declare this function here, get the answer 2. I redeclare the function this time using list comprehensions, and then I do the same function call again. I get the same output in return, right? So that's how I know this thing works. And if you're really a big stickler with minimizing code, you can minimize it further using this. Okay. So what will this do? Let's look through this. For num in nums, this is the iterator, and then what you're storing as an element is num less than 0. Now remember, this is a Boolean expression. What will this do? It will either evaluate to true or false for every case we make, right? So if you go through this example, this will evaluate to false, this will evaluate to true, this will evaluate to true, this will be false, and this will be false. Okay. So now, if you sum that up, we know in the Boolean comparison video that a false is, if you convert it to an integer, it becomes a 0. And a true, if you compare it to an integer, becomes a 1. So if we sum it up, what will this yield? So I have this, and for each of this will be false, this will be true, this will be true, and then this will be false, and then this will also be false. Okay. Now, if I take the sum of this, it is like asking Python to take the sum of 0, 0, 1, 1, and 0 again. Okay. So if I take the sum of this, obviously it returns 2. Okay. Now, if you really want to break that down, num less than 0 for num in nums. Okay. And since I don't have the nums declared, I'm going to paste in the list that I have. So if I look at this, the intermediate output will be false, true, true, false, false, exactly like we had discussed. And then if I take the sum of it, it will evaluate to 2. Okay. So that's another cool way of doing this. Now, which of these solutions work best? The answer is it depends. And again, it's more sometimes a design choice rather than the correct way to do it. There is no right way to do it. Sometimes there is a best way to do it. So as and when things become clear with respect to what problem you're trying to solve, you will learn to choose the best iterator forward. So take a call between using a for loop versus a while loop versus a list comprehension with conditions as well, right? So again, always remember, readability counts. Explicit is better than implicit. So I would rather say this piece of code is way more balanced because it has the minimalistic nature along with being somewhat readable. This is too verbose for me, and this is too trim for me, so that anyone else who's reading my code, if I write it in this cryptic fashion, they really have to dig down and understand what is going on, right? So I'd much rather settle for this rather than this, which is an extreme example, and this, which is another extreme example. Yeah. So that's the piece on lists. Thank you so much for being with me so far. See you in the next video.